Hello, so this is going to be a third video in our three-part video series on how you can use drones to map, process, and analyze a commercial building, such as a shopping mall, with AI. So in our first two videos, what we've shown is how you can actually capture the building, so ensure you've got all the right images in the right places. In our second video, we went through an analysis workflow where you're able to actually process and analyze all of the data. And in this particular video, what we're going to do is we're going to look at how you can actually use AI to not only find issues and damage to this particular building, but also quantify all of those issues. So let's have a look. Right, okay, so we are in the project in Hammer Missions now. So we're using Hammer Missions for this particular project. And essentially, what you see is a commercial shopping mall that has been mapped using drones. I must say that this video is the third part to a video series. So if you haven't seen the first two videos, I highly recommend going and checking out those videos. That will give you some more context in terms of how this particular building was mapped using drones. But even if you haven't seen those videos, I can quickly cover that. So what you see here is essentially a cloud of points. Each one of these yellow and orange points is basically a point where the drone took a photograph of this particular building. And then all of those photographs were then used to essentially stitch together this 3D model that we see on the screen. We not only have the 3D model, but we also have all of the images that make up that 3D model. So if you wanted to look at any particular part of the asset, any part of the roof of the commercial building, we can just click on the 3D model and then come up with all of the images that show us that particular part of the roof. Now, this particular roof, as you can probably tell, has had many issues with respect to all sorts of ponding water. You can kind of see that all sorts of water has been ponding on the roof. And not only can you see this from the 3D model, but you can actually also see this from the images. So on my right hand side over here, you've actually got all of the images show you the ponding water. And if you look closely, you'll notice that you've actually got some of these ponding water. They have been actually marked up in these sort of dotted sort of polygons. So the dotted polygons have marked them up, and that has been done by using AI. So in our second video, we actually went through a workflow where you can actually see how to mark all of these images up so that you can find all instances of the water ponds. So if I was to click on this part of the roof, and if I wanted to see all the water ponds over here, you can kind of see that they have been marked up by AI. So you can kind of see that's all sort of marked up by AI. And you can sort of do this process in a way that's scalable so that you don't have to manually go and find all sorts of ponding water and all the instances of issues on this particular building. This process works for not just ponding water, but also other types of defects, damage, and deficiencies. So if you wanted to sort of actually do this for not ponding water, but cracks, or if you wanted to do it for other types of issues, you can actually do that fairly easily. You just have to follow a slightly different process with respect to how you train your AI to manipulate all of that, but that's all possible. So, yeah, so what I want to do now is I want to actually show you how you can not only find all these instances of ponding water, but how you can actually quantify how much ponding water there is, or let's just say how many instances of ponding water there is. And so to do that in Hammer Missions, all you have to do is once you've got your 3D model and all of the AI based damage detection, you can basically bring all of that together using the quantification tool. So basically, you go into the quantification tool and you let it calculate how many observations there are of each deficiency. It can tell you how many were assessed by a human and how many were AI assessed. I think we're still in that era of AI, but it's really important to build transparency in terms of what work is being done by AI and what work is being done by a user. And so over here, what we can see is that there are 9 observations of ponding water that have been marked up by the user. And then there's about 203 observations that have been marked up by AI. And so you can get this sort of information very quickly. And if you wanted to actually see all those instances, what you can do is you can just calculate all of that with respect to the 3D model. So this will take a few seconds to run. So I'm going to let this run for a second and then come back when we're good to go so that I can show you what the results look like. Right, okay. So what we've got now is basically AI has gone and sort of actually annotated not just the images, but also the 3D model for all the different instances that it's found of ponding water. And you can sort of see that there are labels that have been added to each one of these ponding water instances. So you can sort of see that. You've got all these different labels. And what it's doing is that it's essentially going and creating an ID for each one of these instances of ponding water, so that it can ID each one of them. And what's the benefit of IDing? Well, if you want to actually track all of these damages and all these deficiencies, and you want to track that damage or deficiency against an ID, then you can sort of see how that damage is doing over time. Now, this is just ponding water, but maybe you want to come back to this building in the future and you want to have a look at how that ponding water is doing, or you want to see, like, let's say if it's a crack, how that crack is growing over time. Having an ID really helps in terms of understanding where the issues were in the previous survey and how you might have to actually change those surveys. Now, this is AI, so it's not going to get everything right. For example, it has marked up this particular part of the model as ponding water, which we can see is definitely not the case. But it might be due to the fact that there are these sort of maybe these panels or some of this sort of structure on the roof, which can cause issues. And so you can always go in and change the data. You know, you've always got full control, so you can go in and look at that and see, okay, well, it's identified this particular bit as ponding water, which is obviously not correct. So you can actually remove that from the observation, go into the quantification, and then recalculate all the results. And it's going to basically remove that label so that you've got a much better data set. So you still got to review everything. It doesn't sort of, do all of your job for you, but it does make the job easier where you're not sort of going in there creating an ID for every single issue or every single damage, and you're able to actually focus your time on what needs to be done for this building with respect to repairs. Why are you having those ponding water in the first place? And what sort of suggestions can we make to the people responsible for the maintenance of this roof, whether it's the building owner, whether it's an operator, whether it's a manager? What kind of recommendations can they have from this roof, and what's the best next steps that they need to take? You can export all of this data into a PDF report. Just go into the reporting option, get all the data out into a PDF report. But if you want to find out more about that, we will recommend watching our next video.